and gradually approach its perseverance. And it's faster than anything scientists have observed in this type of object. Reaching over 750 kilometers per second. In just 2 years, we can witness the spectacular sight of stars swallowing their planets. By cosmic standards, it's incredibly fast. But not all things die because of speed. Some people do the opposite. It's because it's running too slow. Kepler's 1658b's orbital speed has recently dropped by a few tenths of a percent. At first glance, it seems trivial. But considering his orbit is very close to the rampage, this change becomes crucial. If the speed continues to slow down, the planet will soon be unable to resist the attractive forces of its star and eventually fall into the stars. And imagine those objects that must face the attractive forces of 3 stars simultaneously. How difficult will its situation be? Veteran Planet is one of them. It's in the constellation Cygnus, located 2,000 light-years from Earth. The planet revolves around a star, and this star revolves around another star. But here's the complication. There is also a distant third star that locks the first 2 stars and planets within its orbit. If we have a chance to go to the K5 floor, we will see 3 suns hanging in the sky at the same time. Different sizes. Planet PH1 is located about 5,000 light-years from Earth. This planet orbits 4 stars simultaneously. This is already amazing. And compared to these complex star systems, some celestial bodies prefer to travel alone through the vast universe. For example, HD 106906b. It's a giant exoplanet. Its mass is about 11 times that of Jupiter. It is about 300 light-years from Earth. Located in the Cross, scientists discovered him. Surface temperatures of up to 1500 degrees Celsius. This extreme temperature indicates that he should be orbiting a certain particle. But the puzzle is, this planet doesn't have any nearby stars. After further observation, researchers discover a potential Jupiter 96 billion kilometers away. This distance is 20 times the distance of the solar track Neptune, and about HD 106906 than usual high temperature. Scientists explain that this is because he is still very young, only 1/350 the age of the Earth. It's cooled down completely. However, due to its orbital characteristics, this baby planet is likely to become a cold, frozen world in the future. Unlike HD 106906b, whose orbit is easy to predict, and H25183b, the gas giant, is not making any sense at all. The planet is about 100 light-years from Earth. Its orbit is extremely eccentric. It comes in close proximity to the star, sometimes farther away to the edge of the entire star system. And here's the interesting thing. Other planets in the same star system have normal orbits. If H25183b were placed in the solar system, it may make frequent attempts to impact other planets. Due to this peculiar behavior, scientists have nicknamed him Planet Whip. The most ordinary celestial bodies in the universe often hide amazing secrets. For example, Refund 2180b. He is about 380 light-years from Earth. At first glance, it's very similar to Jupiter, almost the same size, and yet it's 3 times the mass of Jupiter. That's too heavy for a gas planet. What's even more surprising is that the planet's orbital radius is larger than that of any known gas giant star. But even at this distance from the stars, the surface temperature of this planet can still be maintained at 80 degrees Celsius. This is much lower than other gas giants. Some people speculate the planet's thick layer of gas may hide a true oasis. This might explain why he is so heavy. And sometimes we don't even need sophisticated telescopes. It can also spy on the secrets behind some of the atmosphere, e.g., GJ L32b. He is about 40 light-years from Earth. This beautiful planet is slightly larger than Earth and has a thin hydrogen atmosphere. He didn't specifically direct the scientists to discover this was his second atmosphere. At first, the planet had a thicker gas shell. But because the young stars around it are too radioactive, this atmosphere is completely glassy. Only the bare core remains. However, the planet did not admit defeat. Soon, a new atmosphere was formed through volcanic activity. And here's what's amazing. Scientists have discovered that, and it grows every year. Unlike celestial bodies that undergo tremendous changes, some celestial bodies can be seen in the depths of the universe for billions of years. For example, the planet Methuselah in the constellation Scorpio. It's about 12,500 light-years from Earth, up to 13 billion years. Almost the same age as the universe itself. This planet is located in one of the worst regions in the universe. Each year, there are more than 200 powerful earthquakes and magnetic explosions, but still standing, and 1/200 light-years from Earth. Kepler 36b is bullying its sister Kepler 36c. The two planets orbit each other. Something in common runs amok. When their distance is minimal, massive planets' attractive forces and magnetic fields can trigger earthquakes on asteroids, volcanic eruptions and storms. These disasters happen every 97 days. And it's been going on for thousands of years. And for some celestial bodies, they don't even want to get along with their neighbors. For example, from the 1407 wall, this planet, which is about 400 light-years away from Earth, is known as a cosmic loner. He built a huge ring system around himself. The radius of its largest ring reaches 90 million kilometers. In comparison, Saturn's largest ring is only 480,000 kilometers. If you go from 1407 to 1 to the solar system and replace Saturn, humans will see its ring system in the sky. Replace the existence of clouds. Now the planet is already bothering its star with its massive ring system. Scientists have observed that the odd ring system causes up to 56 days of daylight. The launch of a space telescope has accelerated the pace of scientists' exploration of the western white planet. In early 2023, researchers discovered LHS 475b. He is about 40 light-years from Earth. And here's the exciting part. This planet is not only the exact size of the Earth, and preliminary studies suggest that its atmosphere and temperature could be very similar to Earth's. Perhaps this planet could become a new home for humanity in the future. Deep into the vast depths of the universe, Messi, which is about 55 million light-years away, also has 87 stars. Our cosmic explorers have been tracking him for over 20 years, attracted by his sheer size. But even more special is the strange energy jet ejected from its core. This jet is full of energy, swinging in a rhythmic 11-year cycle. It's like a cosmic waltz. We recently made the astonishing discovery that the black hole of humanity's first Prime Minister is spinning. However, this also raises the key question of how the black hole rotates. Although we have not yet fully revealed the extreme behind it, but there are some theories that do. When a massive star runs out of nuclear fuel, he's going to collapse. If he was spinning, then his remains will spin even faster. It's like figure skating athletes spin faster when they tighten their arms. This process follows the principle of conservation of agitation. As time goes by, black holes attack matter from their surroundings, including gas, even the partial remains of nearby stars. This material is not directly swallowed by the black hole as it spirals down. It's powered by the dance of the black hole. Further accelerate its rotation speed. Sometimes two black holes meet and merge. They perform a cosmic dance within the constraints of the law of profit, eventually form a new rotating black hole. The rotation speed of this newly formed black hole is affected by its initial rotation speed and the merger method. The rotation of a black hole has another curious effect. It drags the fabric of space-time around it. This phenomenon is known as space-time dragging. Although this does not directly increase the rotation of the black hole, but it affects nearby matter and celestial bodies in extremely complex ways. Some supermassive black holes eject powerful jets of energy. These jets are excited by the rotation of the black hole. It has a profound impact on its surroundings. This feedback mechanism could even change the way black holes attack matter, indirectly affect the evolution of its rotation. Therefore, the rotation of a black hole is actually a complex symphony composed by many cosmic events and processes. The oscillation of the jet. It seems to be an elegant dance choreographed by the attractive force interaction between a spinning black hole and its dilute baseplate dance. Scientists have discovered that the jet at the center of Macy's approximately 87 galaxy wobbles at an angle of about 10 degrees. The cycle is 11 years. This rhythm becomes important evidence for the rotation of the black hole. It's like the universe pays homage to Einstein's wisdom in this way, as predicted by his general theory of relativity. A spinning black hole doesn't just spin around in circles. He also drags around space-time structure. This is the phenomenon of time and space delay in the Messier bus parent line. Since the black hole's rotation axis is not perfectly aligned with the new suction cup, this slight misalignment causes the jet to swing gracefully. This not only gives us a glimpse into the secret of the black hole's rotation, it has also filled the scientific community with infinite reverie about the complex operation of the universe. However, the story of black hole rotation is still full of suspense. Some theories suggest that young black holes spin at breakneck speed as they devour stars. But as time goes by, black holes merge with each other, growing into the supermassive black hole we see today. Their rotation speed may become slow and steady. Scientists have also discovered another nearby jet in the Milky Way galaxy, nearly 8,000 light-years away. This jet is waving at an incredible speed. The cycle is completed every few minutes. This is also the fastest wobble ever observed. With the advance of observation technology, we're getting closer to uncovering the truth about the mysterious power source of these jets. Einstein's theory tells us that attractive force is not just an interaction between masses. It's a warping of the fabric of space-time caused by mass and energy. Imagine that. Space-time is an elastic structure. Place a heavy bowling ball in the center of the structure. We'll cause its lower line to form an arc. And if you place marbles on this structure, they don't roll to the center because of the attractive force of the bowling ball. It's because they move along the natural curvature of the structure. Now imagine this bowling ball starting to spin. His autobiography would warp and drag structures around him. This is similar to the saliva effect of rotating celestial bodies on the structure of space-time. The rotation of the black hole not only bends space-time, it will also drag the edge of time and space. The rotation direction rotates in the region close to the black hole world. This effect is particularly pronounced. Attractive forces and relativistic effects have reached their limits. What does this mean for the universe? Any object that has mass or energy, once the rotating black hole is approached, will not only feel the attractive force, you will also feel the effects of space-time being distorted. This causes its orbit to proceed and change its orbital direction. This phenomenon cannot be explained by attractive forces in classical physics. In addition, high-speed energy jets ejected near the black hole's poles may also be affected by the spatiotemporal saliva effect, particles accelerated by a black hole. Perhaps a warping of the fabric of space-time has led them into these jets. This makes these spectacular cosmic jets even more mysterious and vibrant. So space-time saliva is not unique to black holes. It's ubiquitous in the universe. It's relatively small. Even celestial bodies like the Earth, also slightly dragging the surrounding space-time structure because of the autobiography. Scientists probe experiments such as Plan B with attractive force. Using a high-precision gyroscope, the weak saliva effect of the Earth's rotation on space-time was successfully detected. So why is the rotation of a black hole so important? This is because of the way a rotating black hole interacts with its surroundings. Unlike a non-rotating black hole, the way he affects space-time and matter has changed. For humans, understanding these rotations, it is an important step towards unlocking the mysteries of the universe. It could also help us rethink how black holes grow, because the attack process of a black hole is significantly affected by rotation. And here's what's even more amazing. Master the principle of black hole rotation. It may also open up new possibilities for future use of black holes.